Okay, today we're going to talk about unit analysis, also known as conversions. Okay, so unit analysis or conversions is something that you would do with measurement. So there's a system of measurement, and the one that, well, there's kind of two. There's the SI system, which people know as the metric system, and then there's the English system, which is also known as the imperial system. Why we measure is because we want to have a number for some type of, maybe it's the size of something, or uh, which you could measure if you're talking about mass in kilograms. In English, some people might say pounds. The length of something, which would be in meters, and an English system could be, inches or feet. Or you want to measure something like time. The SI base unit for that is seconds, where they're really, the English system, doesn't really have something to go with that. And then you get into stuff that you would find later in science, like amp is electrical current, the mole is the amount of substance. So really, when you get down to it, there's only six basically fundamental units, they're called, and everything else comes from that. So you just need to know your units when you do unit analysis. So what is unit analysis? Well, we'll keep going with that. So you probably remember what is known as the prefixes. So they start in like grade 3 or whatever grade. They start explaining the metric system to you, and you first start maybe learning about centimeters, meters, kilometers, and they get you estimating things. Well, that goes in a certain order because what you have here, it's all based on the meter, but this is what's called the prefix. Okay, and it's important to know the order of those because some are higher than some are lower. And basically, I call it the ladder, but there's a way that these go. And the way to maybe memorize it is that we've got a couple of them that we use: kind-hearted dads buy dogs, cats, mice. So that seems like a bunch of gibberish, but it actually is the prefixes because what it is kilo, hecto, deca, and then the base unit. And this isn't 100% true, but basically you could think of it as in terms of meters, maybe liters, or grams. And then deci, and then centa, and milla. So that's how you can remember the prefix. There's another one that some teachers will also show you, which is ketchup has destroyed babies' delicious chocolate milk. That's another one. There's another one that's King Henry died unusually, meaning the unit, drinking chocolate milk. So there's a few of them. They involve chocolate milk. The reason why this one's not too bad with dogs, cats, mice is it goes from the largest animal to the smallest animal: dogs, cats, and then mice. Either way, when you get into science, you have to know what I call that the ladder, the order of the prefixes. Most people know that a kilometer is bigger than a meter, right? And they know that a millimeter is smaller than a meter. So how it works is these are the prefixes, but then you have to put whatever you're measuring. So if it's meters, that's where you get the km, and then you could get hectometer, and then you get uh, decameter. And you have meter, decimeter, centimeter, and millimeter. Now, something that you probably know as well is I tell people if the metric system had a favorite unit, it would be 10, because every time you go down or up one of these units, you're basically going by tens. And this is when at other times, maybe if someone said 5 centimeters is how many meters? Well, what you would do is there's a way to know, you would move the decimal. And it's really easy. This is what makes the metric system so easy is you move the decimal going up and down the ladder. Now, there's one thing to remember, and that this is down, right, easy. And if it's down and to the right, that's a way to remember that you move the decimal to the right. And if you go up, then it's the opposite way and it's to the left. So here, when I look at this example here, I'm going from centa all the way up to meters. So you got to ask, well, how many times do I go up? Because it looks like maybe there's 3 tens there, but there's really only 2 steps. So I move the decimal twice. And which way am I going? I'm going up. So that's when I move the decimal and I go 1, twice, 2, and that's how many meters a centimeter is. And then if you get another, question where say it's 5 kilometers equals how many meters, well, the good thing about the metric system again is you could say, well, I'm starting at kilometers, I'm going all the way down to meters, and I went down 1, 2, 3 steps. It's down, right, easy. So I would move the decimal 3 spots to the right. Right? So I would have 5,000 meters. Okay, so that is pretty easy. You can all do that, but unit analysis is more than that. So what we're going to take a look at is another way to show moving the decimal. So if we go back to our example of 5 kilometers equals how many meters? Well, really what we want to convert is we want to go from kilometers to meters. And we could all move the decimal, like I said, but there's another way to show this mathematically. And how you do that is you go 5 kilometers, and you're going to multiply by a fraction. Now, some people are saying, why would I do this? But I'll show you later in a harder example where it comes useful. So let's make our ladder again. Okay, and we remember that when you go between steps in the ladder, it's 10. And we've also said to go from kilometers to meters is 3 steps. Well, that's 10 times 10 times 10. And if you know anything about your math, you really just take the 1 and you count how many zeros. That's 1,000. Because the definition is there is 1,000 meters in 1 kilometer. That's what's called a conversion factor. And it's very convenient for the metric system, but other ones you would have to memorize. Like you'd have to know that there's 2.54 centimeters in 1 inch. Now notice what we've done is we've gone from the SI system to the English system. And that's where the convenience of the metric system is with all these tens, is it's the moving decimals part, where this you would just have to memorize. So now just to walk you through an easy example, back to our 5 kilometers, you want kilometers to go away. And just like in math, if I have 2x equals 10 and I want to solve for x, what do I want to go away? Well, it's the 2. So what I do is divide both sides by 2, and then x is now by itself. Well, it's the exact same thing. I want kilometers to go away, so what I need to do is divide by kilometers. So if I have something on top, well, then I want it on bottom to cancel out. So kilometers is going to cancel. Where do I want to get to? Meters. I tell students to start with the units and then worry about the numbers later. Some people will flip them. You'll know what I mean in a second. You've got to put 1,000 here somewhere because 1,000 meters equals 1 kilometer. Some will do it on top. When that happens, you've got to take 2 seconds and say 1,000 meters in 1 kilometer. That doesn't make any sense. You got to know that the 1,000, I'm sorry, oh, forget that. We got to rewind that. So 1,000 meters, the 1,000, they'll put 1,000 down below. And this is where they get mixed up. 1,000 kilometers in 1 meter. That doesn't make any sense. So take a look at where your number is, and it's right there before the meters. So just copy it the exact same way. So now we take a look at it. 1 kilometer. equals 1,000 meters. That makes sense. So we're good. And our units canceled out. Now there's one unit that didn't cancel out, meters. And that's what we want. So everything is fine. And it's numerator, so that's good too. Multiply that together. And of course, you're going to get 5,000 meters, just like moving the decimal did before. So why would you do all this work when you could move the decimal? Well, it's nice to start with an easy example because that explains the math part. So let's do something a little more complicated. You have somebody who has measured area for you. Now you have um, the same example, but it's kilometers squared. They've measured area, and you want to get it to meters squared. So that becomes a little different because you're going up and down the ladder, but you got the square to deal with. Well, what we do is we rewrite the question, multiply by a fraction. You ask yourself, what do I want to go away? Kilometers. Where do I want to get to? Meters. Now, some people will want to do kilometers squared. You do not want to do that. It can work out if you know what you're doing, but you got to know what you're doing, and we're learning this from scratch, so we're going to do it this way. So you only do kilometers to meter, and of course we know 1,000 meters is in 1 kilometer. This will only cancel with one of your kilometers. And you notice you still have a kilometers left over. So you actually have to add another fraction with another kilometer because you want it to cancel with this last kilometer that's left. You have to fill in the remainder of the conversion factor. It's now 1,000 meters in 1 kilometer. And now we do our multiplication. It's 5, and you can notice we have 3 zeros there, 3 zeros there. So we add our 6 zeros. What's our unit? Meters multiplied by another meter. So that is meters squared, which is what we wanted here. So the next way you could look at it is, what if somebody measures the volume of something? And they can leave it in kilometers cubed because volume can also be in something like centimeters cubed, and that's just another prefix in our table of our ladder of prefixes. So we want to get that to meters cubed. So we do the same thing again. We rewrite the problem, multiply by a fraction. We put our kilometers there. That cancels with one of them. You have 2 left over. You have to do it again. Now you have 1 left over. And then you do it one more time to get rid of the last kilometers. And it cancels out. So now when you take a look at it, you have meter multiplied by meter multiplied by meter, which of course is going to give you meters cubed. And you have all those zeros, so now you have 9 zeros. So that is a way that you can take meters measuring length to area to volume. All right, so when it gets a lot of times, especially if you're in carpentry or something, or if you've ever looked at you even just talk to some people, they'll say something in feet or they'll say something in inches. That's because they're going from they're basically talking about the English system. Well, we might want to go to the SI system. So someone might say, well, this is 30 feet, and you want to know what it is in meters. Well, what would have to happen with that is your teacher would have to give you the conversion factor. I know we don't expect people to memorize feet to meters. There's some that people should just know, like there's 2.2 pounds in a kilogram, 2.54 centimeters in an inch. But most of all, you know, you'll get used to those, but majority of the time the teacher will end up giving you the conversion factor. So this is the same thing. You'd say 30 feet, you multiply by a fraction. What do you want to go away? Feet. And maybe you don't know how to get to meters, but you know that 1 foot has 12 inches. So I might not go right away to meters. Maybe I want to try going to centimeters because my teacher's given me this. But I can't go from feet to centimeters right away. I have to go through the inches. So I want the feet to cancel away, and I'm going to get to inches. There's 12 inches in a foot. Now I'm only at inches, and that is not where I want to end up. I need to keep going. So I keep going with my conversion. Inches down below, those are going to cancel, and now I can get to centimeters. And there's 2.54 centimeters in 1 inch. But that's still not where I want to end up because I want to end up at meters. So I have to multiply by another fraction. I put centimeters on the bottom. I put meters on top. Now, if I remember my ladder, I know that centimeters is 2 rungs down from meters. So there's 100 centimeters in 1 meter. You must know that ladder. You have to have that memorized so you can do something like that. And then now you are simply going to take your calculator and you're going to multiply the 30 by the 12. There's no need to divide by 1, of course. You're going to multiply by that, and then you're going to divide by your 100 to get your final answer. So that's an example of how you can use unit conversions going from SI unit to the English system. And of course, you could go backwards the other way. The path is just going to be flipped, right? And don't worry about memorizing something like that or anything. Just follow the steps, follow what is going to cancel out, and you'll get to the right answer. So then you come to another example where unit conversions can be a little different, and that is when you talk about putting units together, which is called a derived unit. And it basically means you're mashing up two different types of units. And we all know one of these types because we all know about speed. So kilometers per hour. There's a unit on top measuring length. There's a unit on bottom measuring time. So those aren't going to cancel out. They are measuring two different things. You put them together and you got a new unit. And maybe somebody says, okay, I want to know if I'm going 100 kilometers an hour, what am I going in miles per hour? Remember, don't put just M because that's going to look like meters. You got to have the I there when you're talking about miles. So if you've ever driven in a car, you can look down and the speedometer will actually have the kilometers there, and down below it will have the miles. Just like on one side of a meter stick, it could have everything in centimeters and everything, and on the back side it would have everything in inches. So when you look at your speedometer, you can see it all at once. But this is how you could do it mathematically, and then because you know you don't have a speedometer in front of your face the whole time, this is what you do. You rewrite the question, kilometers per hour, and you got to decide. You're going to change stuff. I want my hours. Well, actually, they're good at being hours. I don't have to convert them, but I need to convert my kilometers to miles. So here, I'm just going to leave my hours. There's no reason to convert it, no reason to change it, but I need to get rid of kilometers. And of course, if kilometers is on top, I put kilometers on bottom, and I want to get to miles. Now, I need to know that there's 1.609 kilometers in 1 mile. That's another one we'll ask you to know in science. So I know the 1 goes there, 1.609 kilometers, and for anyone that's ever driven in the States, knows that a mile is bigger than a kilometer. It's this much bigger. So this number here is going to be lower, okay, whenever you work that out in your calculator. So now you get another example, one that involves motion. I'm going 100 kilometers per hour, but I want to know how fast I'm going in meters per second. So I'm not converting over to the English system. I'm staying in the metric system, but I'm still changing my units. My kilometers are changing to meters. My hours are changing to seconds. So I have two different types of conversions to do, one for the length part and one for the time part. So I rewrite the question, and I multiply by a fraction. Now, it doesn't matter because you're dividing and you're multiplying. So it doesn't matter which one you start with first. Do you want to do the length conversion first or the time conversion first? It does not matter as long as the path is okay. Kilometers on top, so I put kilometers on bottom, and I want to get to meters. I remember from my ladder that there's 1,000 meters in 1 kilometer. The kilometers will cancel. I have meters left over on top, which is what I wanted. Then I multiply by a fraction. I have hours down as a denominator, right? So a lot of people will get memorizing, oh, I've had kilometers on top, I have kilometers on bottom. But now you have hours on bottom, so it means you have hours on top. These are going to cancel. Now, maybe I don't know how many seconds in an hour. It's 3,600. Some people will know that. But most people, hopefully everybody knows that there are 60 minutes in 1 hour. These hours have canceled, but minutes is not where you want to end up. You need to keep going to seconds. So you multiply by another fraction. You have minutes on bottom, so you put minutes on top, and you want to get to seconds. And most people would know that 1 minute has 60 seconds. You can see right here, the 60 by 60 is how some people know. When you multiply that together, you get 3,600. Some people know that there are 3,600 seconds in 1 hour. Then that means they could do this conversion in two fractions instead of three. It does not matter. So you will get the exact same answer either way. So my final kind of summary would be to rewrite the question, find the conversion factor, create the path with the units only, fill in the numbers, do the path, and then use your calculator. Now there's another topic called sig figs, which has to do with measurement, but I don't believe you do it in math. We only do it in science because we do a lot of measurement. But that is how you do it. You rewrite the question and you start by filling in and canceling out the units that you want. Enjoy unit analysis.